polynomials. So when we're dealing with multiplying polynomials, we're going to be taking and doing some basic things like distributing 3x parentheses 4x plus 3. So just a simple little expression, and we want to multiply the 3x times that. So that's distributive property. So we're going to take this 3x and we're going to multiply it to both of those terms, or as many terms that are in parentheses there. So multiplying 3x times 4x. Remember our rule when we're multiplying, what happens with exponents on variables? We add them together. So those x's both have ones. So when we multiply x times x, it's going to give us x squared. And 4 times 3 is going to be 12. 12x squared for that first term. So that's 3x times 4x is 12x squared. And then we're taking 3x times 3. So 3 times 3 would be 9. And then the x comes with it. And we've distributed that. Okay, so took the factor 3x and multiplied it times 4x plus 3 to get that final polynomial there. Okay. If we had a negative 5x squared out in front and we're multiplying that times maybe negative 2x minus 7, something like that. Same idea. We're taking that whole monomial that's in front, that negative 5x squared, and we're multiplying it, that whole thing, to each piece. Negative 5 times negative 2 would be positive 10. X squared times x would be x to what power? To the third. 2 plus 1 is 3. Yeah, to the third power there. And then negative 5 times negative 7 would be positive 35. And then the x squared comes with it. 10x cubed plus 35x squared. So we've distributed a factor to a polynomial out of that. And they're both positive because it's negative times negative turns to a positive to get those to be positives. Okay. Always make sure you're carrying the sign with you when you distribute. And the sign that's in front of the number is, you treat that like, if it's a minus, it's a negative 7. If it's a positive, treat it as a positive number after that. Okay, so be careful on your signs. That's a very common mistake, is a sign mistake. Most common mistake in math classes from the point maybe 4th, 5th grade, when you start dealing with positive and negative numbers, all the way through my differential equations class that I had to have for getting math degree. It's like calculus 4. It's the most common mistake, no matter what level you're at. So be careful on the signs. Make sure you're just watching that real close, because it's easy to mess up. All right. Now, it's a little bit more complicated looking, but it's actually the same idea. When you take a binomial, something with 2 terms, x plus 3, times another binomial, x plus 4. Some of you may have had an algebra teacher in the past that called this FOIL method, F-O-I-L. I taught FOIL method for several years. I don't call it FOIL method anymore. I just call it distributive property, because that's all you're doing. FOIL method stands for first, outer, inner, last. It's wonderful, but it only works for binomial times binomial. It doesn't work for anything else. So I don't call it FOIL method anymore. I just say, hey, how many distributive properties are we doing here? We're doing 2, because we're going to take this x and distribute it to everything in the other parenthesis. So that's going to be x times x is x squared. X times 4 would be plus 4x. And then I'm going to take the 3 that's here, and I'm going to distribute it to both of them. So it's just distributive property twice in this case. So positive 3 times x would be plus 3x. Positive 3 times positive 4 would be plus 12. Once I've done that distributive property, I'm going to look to simplify. Do I have any like terms in this line right here? Yeah, I've got 4x and 3x. They're both plain x's. So I can take those and put them together. So that'd be x squared. Positive 4x plus positive 3x would be plus 7x plus 12. So distributive property, then look for like terms. Didn't really have to do that in examples A and B because they were so small of problems, you're not going to have like terms there. Okay, when you get to be larger problems, you're going to have more like terms involved. Let's look at another one. Let's say we had x minus 7 parentheses, and then another set of parentheses with 2x plus 5. Okay. So again, it's just distributive property twice. Once with the x that's in front. So x times 2x would be 2x squared. X times 5 would be plus 5x. The next one is the negative 7. Be negative 14x minus 35. Look for like terms. Got a couple in the middle there. 2x squared minus 5 minus 14 to be 9. Excuse me, negative 9. Verify that. 5 minus 14. Get some practice using that calculator. And there we have the final answer there. If you learned it with FOIL method doing this, absolutely keep doing it. It's the same thing. Okay. I did the first, outer, inner, last exactly the same way. The difference is when I have something slightly bigger that I'm just doing. I'm not doing anything different. I'm just doing distributive property over and over. So let's do this one. Nice, neat one. 2x plus 7 parentheses 2x minus 7. So they look very similar. One has a plus sign in the middle, one has a minus sign in the middle. But it's still binomial times binomial. So I'm just going to do distributive property. It's nothing, out of the ordinary here happening until we get to the end. 2x times 2x would be 4x squared. 2x times negative 7 would be negative 14x. And then the 7 to both of those. So that'd be positive 14x and negative 49. Look for like terms. Hey, I got a couple of them in the middle here. I got a negative 14x and a positive 14x. They're going to cancel one another out. Give me 0x. So I have 4x squared. I don't have any plain x's, so I'm not going to write them. So minus 49. So there's a case where the middle terms were like terms, but they happen to cancel each other out. Okay. This is actually called a difference of squares, is what it's called, and we'll talk about that in a little bit when we start talking about factoring. So if you recognize the factors looking like that, kind of look at where they came from. 2x times 2x was the 4x squared. 7 times negative 7 is the minus 49. So when we're thinking about this in terms of where we're headed for factoring, anytime you see a short answer like that, your factors are kind of special sometimes. So, but the math as far as multiplying it goes doesn't change. Let's say we had 2x minus 3 parentheses, and then a parenthesis with x squared plus 7x minus, let's do minus 9. 7 there. Again, this is just a distributed property problem. You can't do what's called FOIL method with this because it's a binomial times a trinomial, which is one of the reasons I don't teach FOIL method anymore. I had a professor in college. We brought up FOIL method in class, and he was from California, is where he went to high school at. And we said FOIL method, and he said, I never heard of that until I came to Tennessee. He said, it's the first place I ever heard of that. And he didn't learn it that way in where he went to high school or college for that matter. But again, it's just distributed property is all we're doing. So 2x times all three of those this time. So this is a little longer because we're multiplying that to three different things. but 2x times x squared, it's going to be 2x cubed. And then 2x times positive 7 be 14x squared. And then a minus 18x. And here's a little, this is not how you have to do this, but I think it's a good way of organizing your work is when you've got something larger like this that you're multiplying, do the first step, that first distributive. And then when I do this next distributive, I'm going to write it underneath it and like line up my like terms vertically. Like negative 3 times x squared is negative 3x squared. And I'm just going to stack it like that because I'm going to put like terms together before I'm finished anyway. I think this just helps, doesn't take up, you don't end up having to take up two different lines that are not organized to put things together. You get your stuff together and it looks a little bit better. And then negative 3 times positive 7x would be negative 21x. And then negative 3 times negative 9 would be positive 27. And then you put your like terms together. So I've stacked it up there. So I'm going to put, hey, 2x to the third doesn't have anybody like it because there's nobody underneath it. So that's just going to be 2x to the third. And then I have 14x squared and negative 3x squared. They're like terms. 14 minus 3 is 11x squared. And then the next one, negative 18x, negative 21x. They're like terms because they both got an x. So negative 18 minus 21, negative 39x. And then the 27 doesn't have any like terms like it, so I'm just going to bring it down. And there's the final product when I've multiplied a binomial times a trinomial. A little bit longer, but again, it's just distributive property. Ever how many times you got to do it. It just happens that way. Okay. X plus 5, and then you'll hear it said quantity squared. X plus 5 quantity squared. That just means squaring the thing that's in parentheses. What does it mean to square something? If I told you to do 7 squared, what would you do? Yeah, you would do 7 times 7. When I say x plus 5 squared, you would do the same thing. You would write out x plus 5 times x plus 5. That's what it's supposed to mean. A lot of people make a mistake on that problem and want to just say x squared plus 5 squared or x squared plus 25, and that's not correct. So be careful of that if you see something with a squared on the outside and it's got addition or subtraction in it, write it out twice and multiply it with distributive property. Don't make that mistake. So x times x would be x squared plus 5x, and then multiply by 5 to both of those. That'd be plus another 5x, and then plus 25. And we get x squared plus 10x plus 25, which is a little bit different than if we'd have got just x squared plus 25. You got to be careful of that. It's a very common mistake to just say x squared plus 25, but then you would be missing this 10x. Okay, so don't miss the 10x. It's in the middle. Same idea here. 2x minus 3 squared. So again, anytime you see that, go ahead and do the extra step of writing it out like this so that you're multiplying two binomials together instead of trying to take a shortcut on this. And then just distribute 2x to both of those. 4x squared minus 6x. And negative 3 to both of those. Another negative 6x, and then a positive 9. It's going to be 4x squared minus 12x plus 9. Don't miss the middle term when you're squaring binomials, especially. I take a pretty easy one, x plus 3 times x minus 3. Same idea, x times x squared minus 3x. Then distribute the 3 plus 3x minus 9. What happens to those middle terms? They go away because they're opposites of one another. Again, that tells us that that's special. It's called a difference of squares. And we'll talk about that when we start factoring a little bit. In just a second. A couple of more examples and then we'll factor. Let's do one more of those difference of squares. 5x plus 9, 5x minus 9. Again, it's just distributive property. 25x squared. Just a little bit bigger numbers here. 5 times negative 9 would be negative 45x. And then move the 9 to both of those. So it'd be positive 45x and negative 81. Middle terms cancel each other out. $25x squared minus 81. What it ends up being there. So multiplying out binomial times binomial, really easy idea. Just got to do a little bit of multiplying. Let's say we had something like this, maybe x plus 2 times x plus 3 times maybe x minus 4, something like that, where they put 3 of them together to deal with. With multiplication, when you're multiplying things together, does it matter what order you do it in when you're just multiplying? No, multiplication, 2 times 3 is the same thing as 3 times 2, right? So it really doesn't matter where you start with this problem, but you're going to pick 2 of them to multiply together and then get that answer and then multiply it by whichever one you hadn't used yet. It doesn't matter which 2 you pick to start with. I'm going to pick these 2 together first, just because I like to work from right to left here, because I'm less likely. The reason I've always done it that way is I'm less likely to forget that thing that's hanging out on the front if I put it out there in the front so that I don't forget it. Okay. If I were to pick the first 2, I'm bad to get in a hurry and I would forget to multiply by x minus 4 at the end. But if I put it out there in the front and I know I haven't used that yet, then I know, hey, you got to do x plus 2 before you're done out of that. So I'm going to do these 2 together first, the x plus 3 times the x minus 4. Technically, it doesn't matter which 2 you do together first. Just pick 2 of them and multiply them together. So here we got x times x is x squared minus 4x. And then 3 times x is 3x. 3 times negative 4 is negative 12. I'm going to go ahead and simplify that before I multiply by this x plus 2 that's in the front. So I've got x squared minus x minus 12. So negative 4 plus positive 3. That's where the negative 1x comes from. Okay. Next step is distribute again with the x plus 2. So x times all of those is going to be x cubed minus x squared minus 12x. And then multiply by the 2. And this is where that stacking comes in. This is where I do the stacking, is when I have a longer one like this. 2 times x squared would be positive 2x squared, and then a negative 2x, and then a negative 24. Again, I'm just stacking up like terms there. And then I put them together at the end to get x cubed plus x squared minus 14x minus 24. Okay. All right. Now, last one of this particular section is kind of an extension of that example. Maybe we got something like this: x plus 2 to the third power. If we're raising something to the third power, what does that mean we do? Multiply it 3 times. So we've got x plus 2, x plus 2, and x plus 2. All right. So pick 2 of them to start with. It doesn't matter. I'm going to pick these 2. And that'd be x squared plus 2x plus 2x plus 4. So that's just distributing. X times x plus 2 is x squared plus 2x. 2 times x plus 2 is 2x plus 4. Combine the like terms. That's going to be x squared plus 4x plus 4. And we're multiplying that by x plus 2. X to the third plus 4x squared plus 4x. And then multiply 2 times everybody. So 2x squared plus 8x plus 16. Like terms stacking up there again. Final answer, just put it all together. X cubed plus 6x squared plus 12x plus 16. All right. Okay, so multiplying polynomials, not a crazy difficult thing there, just kind of sometimes long and tedious. So several operations to do. You got to be careful about that. All right, so let's go to the next section, which is undoing the multiplication of polynomials, and it's called factoring polynomials. So section R4, factoring polynomials. We multiply them. Now let's factor them. Go the opposite direction. Undo the multiplying. Okay. When I'm teaching factoring, I like to go through what I call the rules of factoring. And when we're talking about factoring polynomials, we're not going to get to extremely large polynomials yet. We'll head to that after, in the second half of this course, we'll do some stuff with larger polynomials. But rules of factoring applies no matter how big the polynomials are. Okay, we're dealing with the smaller ones today, and then later in the next week we'll be dealing with larger ones. Right before the final, we'll be dealing with what's called higher degree polynomials. The rules of factoring are the same. Okay, so the number one rule of factoring is make sure that your polynomial is in descending order. And that means that you've got, like, if it's got x to the second power in it, it's x squared plus 3x plus 5. Maybe it's something like that. That's descending order. You look at the exponents on the variable. Okay, this is descending order. X to the third plus 5x squared minus 7x minus 35. That would be a descending order problem, that the powers of x start at the biggest and go down. Make sure it's in that order. It makes factoring tons easier if it is. If it's not in that order, it doesn't mean it can't be done, It just means it's going to be more difficult. So you can always rearrange a problem so that it's in that order. If you will rearrange it so it's in descending order, then factoring is going to be much easier to look at and kind of get going for you. All right. So descending order is first thing you got to do. Second thing you got to do is find what's called the greatest common factor. The greatest common factor, we'll abbreviate that most of the time as GCF. So if I say, what's the GCF? I'm talking about the greatest common factor. Greatest common factor is a number or variable that everybody has in common that will divide evenly into everybody. Okay. So like if you had it, for example, the numbers, if you had a problem that had like 3x plus 9 in it, we know that 3 goes into itself and 3 goes into 9. So the GCF would be 3. Okay. So GCF is the biggest number or group of variables that everybody has. Okay. So looking for everybody to have that. All right. Now, the next thing after you've done those two things, you're always going to look for a greatest common factor before you do any other method. The next step in factoring is going to determine which method you use. We want to count the terms. And remember, the terms are separated by the addition and subtraction problems. So when we've got this one here, the 3x plus 9, that has two terms in it. The x cubed plus 5x squared minus 7x minus 35, that has 4 terms in it. Okay. Remember, terms are separated by addition and subtraction. Okay. So we're going to count those terms. The number of terms that your problem has tells you what method to use. Okay. If it has 4 terms, we're going to use a method called grouping. And I'll teach you how to do that. Okay. We'll teach you how to use grouping. If it has 3 terms, we're going to use this thing I call the X method. I learned factoring by guess and check when I was in high school. I didn't learn this X method kind of idea until I started teaching, actually. Guess and check works. The X method is a little bit more organized way of doing it, so it's not as so much stabbing in the dark at numbers. You really get an idea of where you should go. X method, I'll teach you how to do that in just a little bit. The next one is 2 terms. There are 2 different scenarios that can happen with 2 terms. One of them is that it's a difference of squares. And the other scenario, and squares, the exponent is going to be a 2 on the variable or an even exponent a lot of times for difference of squares. Or it could be a sum or difference of cubes. So I'm going to teach you how to do all of these and how to factor polynomials using these methods here. Okay, so 4 terms, we know we're going to use grouping, and I'll show you how to do that. 3 terms, we're going to use X method, which actually is related to grouping. And then if it's got 2 terms, we're going to look for the possibility of being a difference of squares, or it could be a sum or a difference of cubes, depending on the variable and the numbers that are involved there. So I want to teach you how to recognize each case and how to do that out of that. So we're going to start with some smaller ones and work on greatest common factor style of factoring with this and see if we can build up to the next thing. So instructions will say factor the polynomial. Example A. Let's start with something easy. 5x plus 10. Okay. So when we go through, when we look at any problem, the first thing we're going to do is decide, is that in descending order? So descending order goes by powers of x. Well, the only x in here is x to the first power, and then there's no x's. So this is in descending order. So we're good there. The next thing in rules of factoring is to find the greatest common factor. Always look for that first. Doesn't mean there will be one, but it means you always look for that before you do anything else. So with this one, 5 and 10, 5x and 10 have what in common? What number goes into both of those? 5. So the greatest common factor is going to be 5. So I'm going to put the GCF out in the front of the parentheses. So this is your GCF out here in the front. In the parentheses, it's kind of like reverse distributed property. So what times 5 would get me 5x? 1x. What times 5 would give me a plus 10? Plus 2. If I were to distribute this 5 back out, 5 times x is 5x. 5 times positive 2 is positive 10. So I get the original back if I did distributed property again. You have factored that polynomial using the greatest common factors. That is as far as that one will go. Okay? All right. Now, example B, 6x squared plus 8x. Okay. Again, first thing you're going to check is descending order. Descending order, x squared is in the front, plain x is next. That's all there is to the problem. So yes, we're in descending order. We're good. The next thing we want to look for is a greatest common factor. So let's start with the number part because that's the one we're most familiar with. So what number does 6 and 8 have in common? What number will divide into both of those evenly? 2. Is there anything bigger that will go into 6 that will go into 8? 2 goes into it. Does 3 go into 6? Yes, but does 3 go into 8? No. The only other factor for 6 is 6, and 6 goes into itself, but not into 8 evenly. So 2 is the biggest number. Now, the next thing we got to look about is the variable. This one has x squared. This one has x. Which one has the most? Is x squared more than x? Yeah, x squared's more of them, right? So we look for the least that they have in common. Well, the x and x squared is x times x, right? And this is just plain x. They only have 1 in common, right? So the greatest common factor for x squared and x is just going to be x, okay? It's always going to be the smaller set, never going to be the bigger one. Always going to be the smallest that all of them have with the variables. The number, you're looking for the biggest one that goes into all of them. The variables, you're looking for how many do all of them have, and it's always going to be the smallest number of them that they all have. Okay, so now we got to figure out what's left in parentheses. That's usually the harder part. What times 2 would give me 6? 3. What times x would give me x squared? Another x. What times this 2 in the front would give me 8? 4. Do I need another x to get the x there? No. 4 times 2x is going to give me 8x. So there is the factored form for example B. All right. Now, this one. 10x to the third minus 15x squared. Is that in descending order? Well, remember what we go by for descending order is the variable exponent. What's the exponent on x for the first term? 3, and the next one is squared. So 3 is bigger than 2, so this is the biggest one. So it goes first, and then this one. Now you always go by variables on the number of x's that you've got. Okay, so it's in descending order. Now we want to find a number that goes into 10 that also goes into 15. 5 goes into 10. 5 also goes into 15. The only thing bigger than 5 that goes into 10 is 10, and that definitely doesn't go into 15. So 5 is going to be the number. How many x's do we have in common? 2. So that's going to be x squared for the GCF. This one has 3. This one has 2. They only have 2 in common. Now, getting what's left in parentheses. What times 5x squared would give me 10x cubed? 2x, good job. What times 5x squared would give me a negative 15x squared? Negative 3, good job. There's the factored form for example C. X squared plus 9x to the 5th. Is that in descending order? No, we do need to rearrange this one because we got x squared in the front and x to the 5th in the back. Let's put it in order. So what we do is just rearrange the problem. That's a positive 9x to the 5th. So I'm going to put a positive 9x to the 5th in the front. What kind of x squared is this? Is it positive or negative? Positive, because there's not a sign in front of it. So we treat it like it's positive. So that's why it's going to be a plus x squared. So that plus sign is coming from in front of the x squared. It's not the same as this plus sign here. This plus sign is going with that 9. So that's where you got to look at that sign that's in front of that number or term. Okay. Now, got in descending order. Now, GCF between a 9x to the 5th and an x squared. Just x. I agree with it just being some x's, but how many x's? 2 of them. So it would be x squared in the front. That's the right idea. Good job. Because technically, what's in front of this x squared that's right here? A 1. So 9 and 1. 1 is the only thing they have in common, right? And that doesn't help us really if it's 1 that's in common there. So x squared is all they have in common. So what times x squared would get me 9x to the 5th? It's got to have a 9. And I took 2 of the x's away, so there should be how many left? 3. And then the last piece, what times x squared gets me x squared? 1. It's a plain 1 right there. There's the factored form for that particular problem. All right, let's look at grouping. Okay, so I'm gonna kind of subtitle this here with we're going to use grouping here to try to help us factor some polynomials. Okay, so same idea as before. We want to find descending order. We got to have that first, and then we're counting terms. Okay, so let's say we had x to the 3rd plus 6x squared plus 3x plus 18. Okay. Is that in descending order? Yes. Got x cubed, x squared, x to the 1st, no x's. That's in descending order. So once we've seen that, we're ready to start doing our factoring stuff. So the first step in factoring, every single problem you do, is look for a greatest common factor. Okay, when you're looking for that greatest common factor, at the beginning, you're looking for the greatest common factor across the entire problem. So this one has 4 terms. So we're looking for it across all 4 terms. Everybody's got to have it if it's a common factor. Okay? So we got x to the third, 6x squared, 3x, and 18. Well, these first 3 all have an x, but the 18 doesn't. So that's out. Okay? These last 3 all are divisible by what number? 3, but the front one doesn't have a number in the front. If it's got a 1, that's not divisible by 3. So that's out. So there happens to not be a GCF on this problem. Okay? We look for it. It's not always going to be there. Okay? We always look for it. The first several examples we were doing there, that's what we were looking for, was working on getting a GCF, because the next step is to count your terms. There's 4 of them. If there's 4 terms, that tells us we have to use the grouping method for factoring. Okay, the grouping method is to take a polynomial. If it's in descending order, you can group it into halves. We're going to group the first 2 together and the second 2 together. And I do parentheses around the first 2 and underline the second 2. Notice that I did underline that sign that goes with that third term. That's important. That sign matters. Okay. Now, what we're going to do is we're going to work this like two different problems when we're looking for a GCF. Because if I look at the first half, what's the GCF between an x cubed and a 6x squared? X squared, because this one has 3, this one has 2. Remember, we're always going to take the smallest number on the variables. So that's going to be x squared. What times x squared would get me this x cubed? Just an x. What times x squared would get me 6x squared? 6. All right. So we've factored the first half using GCF. Let's factor the second half using GCF. What do 3x and 18 have in common? 3. Here's where that sign comes important. Whatever that sign is right there, that's what kind of 3 you're going to pull out. If it's a positive, you're going to pull out a positive 3. So we're going to put plus 3. What times positive 3 gets me positive 3x? X. What times positive 3 gets me positive 18? Positive 6, right? Notice those parentheses match. They're both x plus 6's. If that happened, then that means this factors and we did it right. Okay? We got the GCFs out. Now, here's the next step. Okay? So grouping has a couple of steps in it. What does this piece and this piece, if I think about them as 2 separate pieces, what do they have in common? What do both of them have? They both got an x plus 6. So technically, that guy, that x plus 6, is the GCF of those 2. X plus 6. And then what times x plus 6 would get me all of this junk? An x squared. What times x plus 6 would get me all of this junk? A plus 3. Now, I tend to not think about it in that way. I usually say, okay, the parentheses that matches is your first factor. Your second factor is the stuff that's in front of those. That's the way I usually think about this. I don't usually think about it as GCF. Okay. X plus 6 matches. That's the first factor. X squared plus 3 is the stuff in front. That's your second factor. You factored that polynomial by grouping. That's what we're doing here. Okay. Let's try another. Let's say we had 4x to the third plus 2x squared excuse me, minus 2x minus 1. So what's the first thing we always check? Descending order. And is this one in descending order? Yeah, it's ready to go. Okay. Because it's in descending order, I can go ahead and look for my greatest common factor across the entire problem. This one has a lot of the same problems that example E had. 3 of the 4 have an even number in the front, but the 1 doesn't. Okay. 3 of the 4 have an X, but the 1 doesn't. So it doesn't have a GCF. Okay. That's okay. Doesn't always have one. Okay. The next thing to do is count your terms. I've got 1, 2, 3, 4 terms. That tells me that I'm going to do grouping. Okay, because I counted 4 terms. I'm going to group the first half together and the second half together. And I'm going to do GCF for each half. What's the GCF of 4x cubed and 2x squared? 2x squared. Good job. What times 2x squared would give me 4x cubed? 2x. What times 2x squared would get me 2x squared? 1. So that's going to be 2x squared, parentheses, 2x plus 1. Okay. Now, here's the one, this second half here, 2 and 1, do they have anything in common? 1. They have 1 in common. Normally, that doesn't help us, but because we're doing grouping, that does help us here. So when I pull out the GCF, I'm going to pull out a 1, but look at this sign right here. That's a minus sign, so I'm going to make it a negative 1 that I'm pulling out. Okay? Whatever that sign is right there in the middle, that's always going to be the sign that's right there. On example E, it was a plus sign in the middle, so we put a plus sign right there. Here, it's a minus sign in the middle, so we're going to put a minus sign right there in the middle. Now, here's where the magic happens. Not really magic, it's math. What times negative 1 would get me negative 2x? Positive 2x. What times negative 1 would get me negative 1? Positive 1. What happens? Look at the parentheses. Do they match? Yes. If they don't match, this is not working. Okay, they have to match. And that's where that sign in the middle is super important. So then your final answer, the matching factor is 2x plus 1. The stuff in front, 2x squared minus 1. We factor that by grouping. Okay. Grouping is a very, very important part of it. GCF is it's the gas in the gas tank. If you don't have it, you're not going anywhere. So you see, doing GCF is very important because you got to have it to do grouping, and being able to do grouping is important because we're going to have it to be able to do that X method thing that I talked about earlier. So it all interrelates. Everything builds on the next thing. Let's do another grouping problem before we move on to the X method thing. So let's say we had something like this: negative 6x squared plus 25x plus 10x cubed minus 15. All right. So, is that in descending order? No, let's put it that way. What should go in the front? 10x cubed. Then what? Good job. Plus 25x. And then the negative 15, it was in the right spot. All right, now we got it in the descending order. We look for a GCF across the entire problem. 10, 6, well, they got 2 in common. But 25 doesn't have that. Well, 10 and 25 and 15 all have 5 in common, but the 6 messes that up. So no GCF on this problem. That's disappointing, but I think we can deal with it. All right. Now, next thing to do would be decide what method we need to use. So we count terms. How many terms does this have? 4. So if it's got 4 terms, that tells us we're going to do grouping. We automatically know that. So the next step would be grouping the first 2 together and the last 2 together. So again, I like parentheses and underline there. That's not necessarily you won't see that probably in any textbook ever, but it's just my way of grouping things together. It makes sense to me. All right. So first half, 10x cubed minus 6x squared. What's the GCF? 2x squared. Good job. What's that leave in the parentheses? What times 2 would get me a negative? Minus 3, yeah. Be a minus 3 that's in there. 2 times 5 is the 10, and then we got to have another x. 2 times 3 is going to be the 6, and we don't need another x there. All right, what about the second half? 25x and negative 15. 5, is that what sign goes in the middle there? Plus, because this is a plus goes right there. Always. Those are always the same. Never changes. Okay. What's in the parentheses? 5x. What times 5 gives me negative 15? Be a negative 3. Hooray, the parentheses match. That means I did something right. Okay. Means this factors really, really nicely. The first factor is your matching one, 5x minus 3. The second factor is the stuff in front, 2x squared plus 5. We factored that polynomial. Grouping, it's just GCF twice. It's really all it is. It's not, don't overthink it too much. All right. All right. Now, let's talk about the X method. And you may not find, if you Googled X method of factoring, you're probably not going to find anybody's videos but mine. You'll probably find my YouTube videos about doing this. I teach this way, my high school classes. A lot of people, instead of using an X to do their factoring, they'll use a table like this. My wife teaches math as well at one of the local high schools, and she uses a table in this direction. I like the X because it just makes sense to me, and my kids kind of understand that in my classes, and her students understand her way, and it's absolutely fine. It's actually the same method. It's just I give it a snazzy name, the X method. And when I ask kids how you do the X method, they know how to do that, and so let's talk about it. Now, X method is used when we have how many terms? 3 terms. That's when we're going to use X method. If you go back to the rules of factoring, if there are 3 terms, we're going to use the X method, okay? The X method with 3 terms, the way that works is we're dealing with a trinomial. And I'm going to put a trinomial up here. AX squared plus BX plus C. A, B, and C are just numbers, okay? Normally, your X method, you're going to have an X squared and a plain X in the problem, and then a number that doesn't have a letter, okay? A, B, and C are numbers. The way you set up the X method, you multiply A times C and put it in the top of the X. A times C and put it in the top of the X. And then In the bottom of the x, whatever's in front of x is b. That's going to go in the bottom. B goes in the bottom. Okay. A times C in the top, B in the bottom. Okay. On the sides are going to be two numbers, M and N. M times N has got to equal whatever A times C is. And then M plus N has got to equal B. What this does is it forces you to think about the numbers and how they multiply together and how they add together. Okay? Always got to add to be B and multiply to be the same number as A times C. So let's take an easy example to start off with. Okay? What letter are we on here? H. Let's say we had 2x squared. Let's do plus 9. 2x squared plus 9x plus 9. That's our problem we're going to work. We're going to factor this polynomial, it's a trinomial, by the x method. So we're going to set it up. We're going to see how this works with these numbers. A is 2, B is this 9 right here, and C is this 9 right here. Okay. When we set up our x, first thing we want to check for is descending order. This one is in descending order. We're good. Next thing we check for is a GCF. 2, 9, and 9 all of them don't have something in common. So no GCF on this one. Next thing we do is set up our x because it's got 3 terms. On the top, we say 2 times 9. What's 2 times 9? 18. On the bottom, we're going to put b, which is 9. Okay. 18 was 2 times 9. B, that's where that 9 comes from. Now, on the sides, we're going to look for numbers that multiply to be 18 and add to be 9. We need it to multiply to be 18 and add to be 9. Well, the first choice is 2 times 9. 2 plus 9 is 11, not 9. That doesn't work. Well, 1 times 18 is 18. Well, what's 1 plus 18? It's 19, not 9. 6 times 3 is 18, and 6 plus 3 is 9. So that means the numbers on the side should be 6 and 3. Because 6 times 3 is 18, and 6 plus 9, or 6 plus 3 is 9. Okay? Multiply to be the top, add to be the bottom. That's the way it's always got to be. Now, here's the beautiful thing about X method. We take this problem and we turn it into a grouping problem. So I'm going to take 2x squared, and instead of putting 9x in there, I'm going to put 6x plus 3x. I'm replacing b with my pieces from the side of my x. Okay? You're going to replace the middle term with the two pieces you found in your x. Okay? So that we can do grouping then. Okay? When I learned this in high school, my teacher said, okay, just set you up 2 parentheses and start guessing. And you said, okay, well, I know it's got to be 2x times x. And then you had to start guessing about the rest of the thing. I was able to do it, but I could understand how folks couldn't do it because it's just it needle in a haystack kind of thing if you're not good at numbers and really catch on to the number sense really, really well. So here, this gives us a system to go by. We find that what works in this x, and then we take this problem and we do grouping with it. Replace the middle term with the 6 and the 3 that we found here. Okay? because 6x plus 3x is still 9x. So we've just taken this problem and rewritten it in a clever way that makes it easier to do. Okay, so GCF of the first half, 2x squared and 6x would be 2x, leaving x plus 3. GCF of the second half would be what? 3, and it's a plus right there, so I'm going to pull a plus right there, positive 3. That'd be x, positive 3 times what gives me 9, positive 3. Notice that the parentheses match. That means I did it right. I'm going to get x plus 3 for the matching piece, and then the stuff in front is, and now we have factored a trinomial using the x method, which secretly uses grouping. So we're taking, mathematicians are notorious for taking things that look like something else and turning them into things that we're familiar with. Okay? Take something you don't know anything about and make it look like something you know a lot about. And then it makes the problem easier. That's what math is all about. This next Tuesday, when we come back, we'll take these problems and actually solve them later on, which we will take them and turn them into easy linear equations that we know how to solve. And I'll show you how to do that later. All right, so let's take another problem. Let's get that x method some more practice. Say we had x squared plus 7x plus 12. Again, we're going to go through the rules of factoring. First thing is descending order. This one is in descending order. X squared, plain x, no x's. Good. GCF, x and 7 and 12 don't have anything in common, so there's no GCF. The next thing is, hey, there are 3 terms. That tells me I've got to do x method. What number is in front of x squared up here? There's technically a 1 there. So we're saying 1 times 12 to get 12 up top, and then the 7 goes in the bottom. So we need the numbers that multiply to be 12 and add to be 7. 3 times 4 multiplies to be 12. 3 plus 4 is 7, so we know that's the right 2. Okay? The next step is replace the middle piece with 3x plus 4x. Just replace the middle piece. The 12 comes with it. Okay? So instead of 7x, we're splitting that up into 3x and 4x. And then group. X and 3x, x squared and 3x have x in common. 4x and 12 have 4 in common. Matching parenthesis, stuff in front. Notice when there's a 1 in front of x squared, notice how our factors match our x. If there's a 1 in the front, your factors, positive 3, positive 4, up here we got positive 3, positive 4. That can be a shortcut sometimes that you can do. But it only happens if there's a 1 in front of x squared. If there's anything else there, like the previous example, we had a 2 in front of x squared. Notice we had 6 and 3 up here. That's not what's here. Okay, so these that have something else in front, you can't take a shortcut on. You got to do it the long grouping way. With the ones that have a 1 in front of x squared, the shortcut is, hey, if you can figure out what goes in the x, the answers are going to be, the factors are going to be the same. So here we found out it's 3 and 4. Hey, it's x plus 3 and x plus 4. You can take that shortcut. We'll see that as we do. We're going to do several more examples. I want to show you, when that can help and when it doesn't help. Okay, let's look at this problem. 6x squared minus 7x minus 5. So throwing some negative signs in there. So 6x squared minus 7x minus 5. Again, go through all the steps on the rules of factoring. Descending order, GCF, then count terms. So it is descending order. There is no GCF. 3 terms. That tells me to do this X method. Okay. What goes in the top of my X here? Try again. Remember, we got to multiply A times C. 6 times -5 would be -30. And then on the bottom will be -7. Okay. And then we need to multiply to be -30 and add to be -7. So when there's negative signs in there, it's a little tougher. But when you multiply to be a negative, you know that one of them's positive and one of them's negative. So think about numbers that multiply to be 30 and then start messing with the signs. So I'm thinking, 6 times 5, I've already done that one, but they're only one apart, so that's not far enough apart. 15 times 2, 10 and 3 would work. 10 and -3. What's 10 plus -3? 10 plus -3 is +7. So if we swap the signs, -10 plus +3 is -7. So these are the ones we want to use. Okay. So be careful of your signs. Always check that addition step when you've got negatives involved. Okay. So we got 6x squared. It doesn't matter which one of these you put first, -10 or 3. It doesn't matter. I'm going to put the 3 first because I can see GCF of 6x squared and 3x. That's easy to do. So I'm going to put plus 3x minus 10x minus 5. Technically, it doesn't. If you wrote this 6x squared minus 10x plus 3x minus 5, it'll work the same way. The final answer will be the same. I'll work it both ways here to show you that. But group it. The GCF of 6x squared and 3x be 3 and x. 3 goes into 6, 3 goes into itself. And that would give us 2x plus 1. And then the GCF of -10x and -5 would be -5. That'd leave us 2x plus 1. The matching factor, 2x plus 1, 3x minus 5. If you did it the other direction, if you didn't put the 3 in the front, you put -10 in the front. Same stuff happens here. You get GCF of 6x squared and -10x would be 2x. And leave you 3x minus 5. The GCF of those two is 1, so that's plus 1. 3x minus 5 is a factor. 2x plus 1 is a factor. They are the same. They're in a different order, but the multiplication, it doesn't matter what order you write them in, it's the same. So no matter what, in that middle part, that step before grouping, it doesn't matter what order you put the sides in the problem in. It works the same. Okay. So I always kind of try to think about it. What would be the easiest GCF to get? Is the way I think about it when I'm doing that problem. Okay. So there we had a negative on top and bottom of the x. So let's try this one. 4x squared minus 11x plus 6. All right. Descending order, check. GCF 4 and 11 don't have anything in common, so I know nothing else matters. So that's no GCF. So I'm ready to start my X method. What goes on the top of this X? 24. Good job. 4 times 6 is 24. We want it to add to be negative 11. So that sign in the middle there, that's a negative 11. So we got to think a little bit here about when you multiply to be a positive and you add to be a negative, you know both numbers have to be negative, right? That's the only way to multiply to be positive is negative times negative or positive times positive. So if it adds to be negative, then they both got to be negative. So what numbers could do that? Negative 12 and negative 2 would be negative 14. That was close, but not quite. 24 and 1 would be 25. Not quite. 6 and 4 is 10. It's close, but still not right. There's one other option. 8 and what? 8 times 4 is 32. 8 times what is 24? 8 times 3 is 24. So negative 8 and negative 3. The better you are at multiplication tables, the better you are at factoring. That's what I always tell my high school students that have somehow gotten by and not known the multiplication tables through up to when they're freshmen in high school. I always tell them at the beginning of the year, go to the dollar store and buy you some flashcards for $1, or they might be on sale. It might be 50 cents. But if you'll do those flashcards every day and know your multiplication tables, you're going to be so much better at what we're going to be doing in there. And the factoring is where it always shows up. The ones that are really good at multiplication tables may not be good at much of the other stuff that we've done, but they can factor because they know their multiplication tables. So knowing those can really help you here. So next step is fill in the middle. 4x squared. I'm going to put minus 8x minus 3x plus 6. Kind of makes sense that I would put the 8 with the 4 because 4 and 8 is easy GCF, and that the 3 would go with the 6 because 3 and 6 makes it easy GCF. So that's kind of the thinking that I use in what order to put them in, because it doesn't matter what order you do, it'll work, but I try to make it as easy on myself as I can. Next step is group. 4x squared and 8x have a 4x in common. Be x minus 2. Negative 3, x minus 2. So we got x minus 2, 4x minus 3. We factored our trinomial by X method, which led to grouping. All right, let's try this one. This one has 1 in front of x squared. A 1. So that tells me, hey, if I can fill out the x, I can go straight to my factors. That's what I want you to kind of catch on this, is that there's a shortcut to this if there's a 1 in front of x squared. If there's not a 1 in front of x squared, it's any other number, you've got to do grouping. But if there's a 1, then there's usually a shortcut. And if we can fill out the x, we get the shortcut. So we want to multiply to be negative 14 and add to be 5. So we'll think about things that multiply to be 14. 2 and 7. Which one needs to be negative? If I do negative 7 plus 2, that's negative 5. That's not what my x had in it. It had a positive 5 in it. So that would be 7 and negative 2 adds to be positive 5. So the 2 needs to be negative. Because there's a 1 in front of x squared, I can shortcut to my factors. X minus 2, x plus 7. Because there's a 1 in front of x squared. That's the only time I can do that. If there's anything else there, I've got to do grouping. I can do grouping on this one if I want to. If I'm not real comfortable with that shortcut and I do the grouping, I'm going to end up with the same answer. I'd have x squared minus 2x plus 7x minus 14. If I did the grouping, I'll do it fast. And then plus 7. Same thing. X minus 2 is the matching pair. Then the stuff in front is x plus 7. So the grouping gets you the same answer. But if there's a 1 in front of x squared, you can go straight down here to the factors out of that. That's the shortcut that you can take. Not a whole lot of shortcuts in algebra, but that's one of them that you get to use. That really works out nice. Okay. So descending order, GCF we've done, grouping we've done, X method we've done, which involves grouping. So we've done those things. The next thing to look at is when there's only two terms in the problem. So we're going to look at the difference of squares first. So difference of squares. A difference of squares. If you have two things that are subtracted that are squares, that's a difference. Mathematics, difference is a minus sign. Okay? Subtraction. Difference of squares is subtraction of squares. The factors are always splitting that up. One's a plus, one's a minus, but the factors are the same. The examples that I can show you here, let's start with something pretty easy, x squared minus 4. The idea here is to look at it and go through the steps of factoring. The rules of factoring are descending order. This one's in descending order. You got x squared and you got a minus 4. That's descending order. GCF. They don't have anything in common on this one. Then we count terms. There are 2 terms for this problem. 2 terms, then that tells us to jump to either the differences of squares or the sum or difference of cubes. The reason I know this is a difference of squares is I look at the exponent. It's squared, right? Cubed would be a 3 exponent. That's how you know, okay? So this is a difference of squares. So the idea is to rewrite the problem as 2 squares. I'm going to try to rewrite it as something squared minus something squared. If I can do that, then I can take this little shortcut here. Well, what squared gives me x squared? X. What squared gives me 4? 2. 2 squared is 4, right? So we've rewritten this problem as a difference of squares. It's something squared minus something squared. That allows us to take it and factor it. X in the front of both of them, 2 in the back of both of them. One's a plus, one's a minus. And you're done. Okay. If I did the distributed property and multiply this back out, we saw that one earlier when we were doing the multiplying polynomial section. X times x is x squared. Negative 2x, positive 2x. That cancels each other out. Positive 2 times negative 2 is negative 4. It gets you the same answer back out of that. So this is the way you're going to undo that. Factoring it is breaking it apart. Let's take another problem. Maybe something a little tougher. 16x squared minus 25. Well, anytime we get numbers in the front there, we got to think, okay, well, there might be a GCF. Does 16 and 25 have anything in common? No, nothing in common between 16 and 25. So I look at it and say, okay, well, there's only 2 terms, and there is a minus sign in the middle. and the x has a squared on it. So that tells me this could be a difference of squares. I'm going to try to rewrite it as squares. What squared would give me 16x squared? 4x. Very good. What squared will give me 25? 5. What are the factors for that problem? What goes in the front of both of them? 4x. What goes in the back of both of them? 5. One's a plus, one's a minus. It doesn't matter which one you make the plus and which one you make the minus. I usually just do the plus first. It doesn't matter. One's a plus, one's a minus. Let's try this one. 25 x to the 4th power minus 144. So this one's a tough one because it's in disguise. Now, this one's hard to determine that it's a squares because you don't have a 2 on the exponent on the x, but you do have an even number. So anytime you see that even number on the exponent there, and it's only 2 terms with a minus sign in the middle, that's when you think, okay, well, I'm going to try squares, just because if it'll do anything, it'll do squares out of that. So we rewrite that. What squared gets me 25? 5. What squared would get me x to the 4th power? X squared. That's the trick right there. And then the 144 is what squared? 12 squared. Good job. And then the shortcut on the factors, 5x squared plus 12, 5x squared minus 12. Differences of squares. If you can rewrite them like this line right here, then it factors as that. An example of one that does not factor that way, but kind of looks like it should, might be something like maybe it's 16x squared minus maybe it's minus 15. That looks like a difference of squares, but I cannot write the 15 as a number squared. 15 is not a square number, so this doesn't work. So that means that's not a difference of squares, which means it doesn't factor, and you would call this prime. Prime is another way of saying does not factor. We can call that example P. Because we cannot rewrite the 15 as something squared. So difference of squares can always, if you can factor it that way, you will be able to rewrite it as squared minus squared. Manipulating the problem to make it look like something that we know something about. All right. Last thing on the rules of factoring stuff is taking the different sum and difference of cubes. Okay. Sum and difference of cubes. There's really no better way to learn how to factor them. Still difference than to just memorize the pattern. There's always a pattern to that. If we can cube something or rewrite it, it's kind of the same idea as the difference of squares. Sums and differences of cubes are talking about a sum of cubes is plus sign between them. The difference of cubes is a minus sign between them. Okay? The way the pattern works is you've got a short piece and a long piece. If I can rewrite it as a sum of cubes like this, the short piece is going to be the same. So if this were like x cubed plus 3 cubed, it would be x plus 3. And then the long piece, well, you used up one of your x's, so you got x squared left over. You used up one of your y's, so you got y squared left over. The middle piece is the product of the two. And then you change the sign. Okay. On a sum, the short one has a plus. The long one has a minus. On a difference, it's the other way around. It's x minus y, x squared plus xy plus y squared. This last term is always plus. Never changes. Okay, always plus. All right. Now, so we're talking theory here. If you'll memorize these patterns, it's going to help you factor these. Let's do some actual examples of that. Say we had x cubed minus 8. I can rewrite that as a cubed because it's x to the third power. What to the third power gives me 8? 2. 2 times 2 times 2 is 8. It might be helpful for you to make yourself a little chart where you got, x and x to the third. 2 is 8, 3 is 27, 4 is 64, 5 is 125, 6 is 256, I think is right. You could just make yourself a little chart so that you know because cubic numbers we don't do a whole lot of. Square numbers we've done quite a bit of over the years, but cubic numbers we don't do as much. 6 is not 256, it's 216. All right. 216, not 256. Sorry about that. All right. Now, because we could rewrite it as cubes, difference of cubes, so I'm going to go to this pattern. The first piece is x. Well, that's what's in parentheses here. So that's going to be an x. Minus 2. There's the short piece. The long piece, I'm going to have x squared because I'm squaring what's left in here. So that's x times x. It's x squared. The middle piece is a plus, and then I'm multiplying these things together. 2 times x is 2x. And then the last piece is I'm squaring what's in here. 2 squared would be 4. And I've factored that. That's all you can do to that. If you know that pattern, that's what's going to happen. Okay? It will never factor any further than that. Let's do another one. The pattern is the key. If you don't have the pattern, it's tough to do the rest. 64x to the third plus 27. So there's a good sum of cubes. 64 is 4 to the third power. So that'd be 4x inside of there. 27 is 3 to the third power. So there's a 3 inside of there. Short piece, long piece. Short piece, take the stuff that's inside of the parentheses and add it together. 4x plus 3. Straight up, just exactly that. The long piece, you're going to take the first part and square it. What happens when I square 4x? 4x times 4x would be 16x squared. And then because it's a sum of cubes, my pattern for a sum of cubes, the middle piece has a minus sign. So I'm going to put minus, what's 4x times 3? 12x. And then a plus sign, and I square what's in here. 3 squared would be 3 times 3, which is 9. And I factored that by sum of cubes. It really does just take memorizing the pattern and practicing it as you go. It's not rocket science as far as that goes. They're not going to throw really extremely hard ones at you. Cubic numbers get big fast. I mean, we only did the chart to 6 and got to 216. Well, 7 is 343, and you keep going up. The numbers get big fast if you got cubic numbers. Okay, so be careful of that. Make sure that you're paying attention to those sort of things out of that. All right, just takes practice with the factoring. It doesn't. It's not going to get extremely difficult. It's the same ideas. Follow the rules, descending order, GCF. Then how many terms do you have? And that tells you what to do. And it's just like the examples we've done there. Okay. All right. We've got 2 more little sections to do here. These are shorter, much shorter than this one section was. So we're going to do those, and that'll finish us up for today. We'll be out of here in probably less than 30 minutes if y'all can handle it. Let's just push through and get out of here, and then you got Thursday off coming up. So let's just go ahead and jump into square roots. So we're going back to that remedial section or the review chapter, and talk about square roots. So anytime you see us go to R.7 or R anything, this is not going to be too difficult of stuff. So we're going to talk about square roots, radicals. Okay. Square roots or radicals is another name for that. So the idea here is that we're going to simplify square roots. And let me check my calculator real quick to make sure I'm in the right mode. And check something real quick. All right. All right. Making sure my calculator was in the right mode to do this right. All right. So simplifying square roots is what we're going to be doing. So simplifying square roots is taking the square root of a number and not getting the decimal part for that. It's always easy when it's a nice, easy square root. We know the square root of 9 is 3. But why is the square root of 9 3? Well, it's because 9 came from 3 times 3. There was a pair of 3s. So when we're simplifying, when we're doing a number that isn't as nice, maybe like square root of 12, that's not as nice a number, okay? Because 12 doesn't have a good square root. And if I went to my calculator and I tried to do square root of 12, I can do square root of 9. To get the square root with the graphing calculator, you hit second, and then the number just up and to the left of 7 is the square root symbol. If I type in 9, it's going to give me 3. That's the right answer. But if I type in the square root of 12, it cranks out this big ugly decimal. And we don't want the decimal. We want the exact solution here. So we're not looking for a decimal equivalent of that. You can check with decimal equivalents. When we get the simplified version of this, I'll show you how you can check that and make sure it's the right number. Breaking down the 12, think about doing a factor tree from like elementary school stuff. What's a combination that multiplies to be 12? 3 times 4. 3 is a prime number, so we don't go any further with it. But 4 will break down to 2 times 2. 2 is a prime number, so each of those 2's stop. We don't break them down any further. So you're always trying to break down to prime numbers. Then because we're doing square roots, we look for pairs, sets of 2. There is one set of 2's. This 3 does not have a partner, okay? So the way that simplifies is you get a 2 on the outside of the square root and a 3 left on the inside. This 2 is from that pair of 2's. That 3 is the 3 that's underneath. It doesn't have a buddy. Okay. Pairs One representative from each pair goes on the outside. Anybody that doesn't have a partner goes back in. Okay. All right. Now, on the calculator, if you wanted to check, make sure that's the same number. We did square root of 12. We got this decimal. If I did 2 square root of 3, I better get the same decimal. It is exactly the same. Okay. So that tells me, hey, I simplified it correctly. Okay. Let's look at maybe square root of 18. Different number there. 18. What's one of the ways to multiply to be 18? 2 times 9. That's good. 2 is a prime number, so I know that this branch of the factor tree is done. 9 is not a prime number. I'm going to break it down. 9 is 3 times 3. Hey, there's a pair. Those are prime numbers, so I know I'm done. And I got a pair of 3s. So that's a 3 on the outside. This 2 does not have a partner, so he goes back on the inside. 3 square root of 2. Let's do one a little bigger, like 108. Bigger number. If I'm not sure about a number, a lot of times I'll just go ahead and do the calculator, square root of 108, and I know, hey, I know I can simplify that somehow, or it's not going to have a nice square root. So I'm not sure what it is, but I'm just trying. So I'm thinking, how can I break down 108? What numbers go into 108? If you know your multiplication tables, this makes this easier, obviously. But if you don't know them, you can just start with the easiest thing. I know 108 is even, so I know 2 goes into it. So on my calculator, I just say 108 divided by 2. That's 54. So I put a 54 over here. And then I don't know much about 54, but I do remember that 9 times 6 is 54. I just happen to know that multiplication table. And 9 is 3 and 3. 6 is 3 and 2. Okay. All of those are prime now. The ends of the branches are prime. That's the only ones I'm looking at. So I have a pair of 3s right there. So that's a 3 on the outside. I have a pair of 2s. Those 2 guys go together. So I put a 2 on the outside, and I multiply it times that 3 that I've already got out there. This 3 right here doesn't have a partner. So he goes back on the inside. So that's going to be 6 square root of 3. Anytime you multiply, you bring more than one thing out, you multiply it together. I'm going to check that with my calculator to make sure that 6 radical 3 is the same as the square root of 108. 6 square root of 3, 10.39 and some change. It's the same number out of that. So simplifying using the factor tree method is absolutely useful. If there's a negative sign out in the front of it to begin with, so 300 under there, big number. Now that's so square root of negative 300. I don't know much about 300 other than it's 3 times 100. And that's 10 times 10. Here's one of those where, hey, I could actually stop right here and not break down the 10s any further because I got a pair of them, right? So that's a shortcut. Got a pair of 10s. And then that 3 that doesn't have a buddy. That negative sign that was out there to begin with just carries over and becomes negative 10 square root of 3. And you could check that with your calculator as well to make sure that's correct out of that. So simplifying with the factor trees is the way to go about doing things there. If for some reason you had to simplify a fraction, do something easy there, square root of 16 over 25. The way to do that is to split it apart. we happen to know the square root of 16 is 4, and we happen to know the square root of 25 is 5. Much easier to think about it in that way instead of thinking about it in terms of a fraction. So just split it apart and then do your simplifying out of that. If you had something like this, maybe the square root of maybe 28 over 25. Split it apart. We know the square root of 25 is 5, but the square root of 28 is not a nice number. So I'm going to do the 28 with the factor tree method like I was doing earlier. So multiply by 28, that'd be 7 times 4, and 4 is 2 and 2, 2 and 2. So there's a pair of 2s. That'd be 2 square root of 7, and you've simplified it like that. So splitting it apart and simplifying the square roots is how you would do a fraction if you encounter that. They don't put a whole lot of those in here as far as that goes. Now, other thing in this section would be multiplying radicals together or square roots together. What letter I'm on? H, not I. Square root of 6 times the square root of 12. The rule is multiply first, multiply insides and outsides. If it's on the inside, multiply them together. If they're on the outsides, multiply those together. Okay, and then simplify. So here we have square root of 6 times square root of 12. There's nothing on the outside, or technically there are 1s out there. So 1 times 1 is 1. On the inside, we're going to multiply 6 times 12, which is the square root of 72. And then I'm going to simplify that. Okay, simplify. So that would be 6 and 12. And then 6 is 3 and 2. 12 would be 2 and 6. 3 and 2. So there's a pair of 2s and a pair of 3s. So that's going to be 2 times 3 square root of 2, because that 2 doesn't have a buddy. 6 square root of 2. If there are numbers on the outside, maybe 3 square root of 8 times 5 square root of 12. But remember, outside times outside, inside times inside. So 3 times 5 on the outside, 8 times 12 on the inside. Just multiply it like that. 15, then 8 times 12, is that 96? And then simplify the 96. I know it came from 8 times 12, 4 times 2, 4 times 3, 2, 2, 2, and 2. 2 pairs of 2s, and then a 2 and a 3 left over. So that's going to be 15 times a 2 times a 2, and then 2 times 3 left on the inside. The 15, it was already there. Each 2 is a representative from the pair of 2s. 1, 2, 1, 2. Okay? So that'd be 15 times 2 is 30, times another 2 would be 60, and then 2 times 3 is 6 on the inside. All right. So simplifying square roots, factor tree method works really wonderfully. Some people teach by just dividing by square numbers, but that requires you to memorize a whole list of square numbers that just is extra information. I think the factor tree is a little less memorization, a little more function to it. All right. Last section of the day, is complex numbers. Okay, and it's very much related to this. Chapter 1, Section 3, complex numbers. Complex numbers come from taking the square roots of negatives. So a -1 under the square root is where this I is representative from. Okay, -1 under a square root gets you an I. So anytime there's a negative under a square root, you can automatically bring out an I and change it to a positive number. Okay, if you square I, you get -1. If you take I to the third power, you get -I. We'll see this simplifying a little bit later on, but I'm going to show you how to do a lot of this with your calculator because it'll do some complex numbers for you. I'm going to show you how to do some of that. And then I to the fourth power is 1. Okay, so that's the complex number chart. You might want to have that handy sometimes. When you're dealing with a complex number, it's in this form, A plus BI. This is the real part. This is the imaginary part. Complex number means you put them together. And then we're putting them together with either addition or subtraction here. The imaginary part, the imaginary numbers is an unfortunate naming accident in mathematics. There were a couple of guys that were pretty smart way back a lot of years ago, and they were kind of like pen pals. They were both professors, and they were teaching, and they would try to challenge each other in problems. And they were learning how to solve polynomials, and they knew that there should be a certain number of answers, but they at that time didn't know how to find all of them. So they started calling these answers that they couldn't find imaginary answers, and that's where the imaginary number idea came from, because they didn't know a better way to describe that. So they started calling them imaginary. The name stuck, and we probably could come up with a better name now, but we'll just stick with what we already know, and we'll call them imaginary numbers. So let's talk about simplifying some square roots where the imaginary part comes involved. So simplify, we'll start with that. I'm trying not to rush here, so it's been a long morning. Same idea as before. We got the negative underneath there, so we know automatically that there's an I that's going to come out. And then we're going to break down the number just like we did before with the factor tree. 24, I could do 2 times 12, 6 times 2, 3 times 2. I've got a pair of 2s, and then the 3 and the 2 left over. So there's a 2 that comes out that's with that I. And then on the inside, I've got 2 times 3, which is 6. So 2I radical 6, or square root of 6, is what that ends up. The I comes from the negative being on the inside of the square root. The number part is exactly what we just went over from R.7. If you had the square root of -72, same idea. We know because it's negative that it's going to have an I on the outside. And then we would break down 72. I know that's 9 times 8. Nine is 3 and 3. 8 is 4 and 2. 2 and 2. So there's a pair of 2s and a pair of 3s. So 2 times 3 on the outside is 6. On the inside is this 2. So 6I radical 2 for that one. Example C, maybe a simpler one, but sometimes can cause confusion. Maybe is the square root of -35. So 35 breaks down to 7 times 5, but those are both prime, and neither of them have a pair or a buddy to go with them. So they're nothing's going to come out. except for an I because it's a negative 35. So it's going to be I square root of 35, just like that. Okay. Be careful of that. That's pretty easy. All right. When we're dealing with complex numbers, the next thing I want to show you is some stuff that we can do with the calculator to help you out with the complex numbers. And that's adding, subtracting, multiplying, and dividing. So doing operations with complex numbers. Adding and subtracting is really easy, and I don't normally do that with the calculator. I'm going to show you that because we're on such a time crunch as far as the summer class goes. But I'm going to show you both ways with it. The multiplying and dividing, I usually do show my classes to do that with the calculator just because it shortens things up so much and simplifies for you. So if we're going to add and subtract two complex numbers, so 3 plus 5i plus 6 minus 2i. If you were going to do that by hand, it is exactly like you would do a polynomial. You put the like terms together. 3 plus 6 is 9, and then positive 5 plus negative 2 is 3. And it's 9 plus 3i. What I want to show you is your graphing calculator can do that as well. So with your graphing calculator, hit the mode button and make sure that on the line that has real, you can see where it's blinking there, real a plus bi and then re to the theta I, make sure that the second choice is darkened in there, that it's a plus bi. Just arrow over to that and hit enter and make sure it's darkened in. Okay, make sure that that's the form that your calculator is working in. Okay, then hit second and mode to get back to the regular calculator screen, or turn it off and turn it back on. It does the same thing. Okay. Now, the next thing would be to put in that problem. So we're going to put in parentheses 3 plus 5i. So to put the 5 and to get the I, we hit second and the decimal point. Second and the decimal point gets you the I. Close the parentheses, plus parentheses 6 minus 2 second decimal point to get the 2i. Hit enter. It does the complex number for you. 9 plus 3i. Same thing I got when I did it by hand. Okay. And the reason I'm putting them in parentheses is to emphasize that this is one complex number, the 3 plus 5i, plus another complex number, 6 minus 2i. Okay. We're going to do a few more of those so I get some more practice with the calculator on that. So let's do a subtraction problem. 3 plus 5i minus 4 plus 2i. Okay. If I did this by hand, 3 minus 4 is negative 1. 5 minus 2 would be 3i. This is what I should be getting. If I do it with a calculator, I'm going to do, again, 3 plus 5 second decimal point minus parentheses. What did I use for the number? 4 plus 2i. 4 plus 2 second decimal point. Hit enter. Negative 1 plus 3i. That's exactly what I got there. Adding and subtracting, it's like terms is the name of the game. That's all it is. Okay. Multiplying is where the calculator really shines and helps you out a lot. Okay. Is when you're multiplying. So let's take 3 plus 5i times 6 minus 2i. So multiplying it out. If I were going to do this by hand, this is what it would take. Okay, I'm going to show you how this would have to be done by hand, and then show you how quick and easy it is to do with the calculator. Okay, so I would do distributive property just like I did at the beginning of these lessons with polynomials. It's multiplying 3 times 6 is 18. 3 times -2 is -6i. And then I would multiply 5i times 6, which would be 30i. And then -10i squared. And then I've got to simplify that. So that'd be 18 minus or plus 24i. And then I squared, remember, was -1. If we go back to that chart back at the beginning of this lesson, I squared turns into -1. So that's going to be plus 10. So then I've got to simplify that. That'd be 28 plus 24i. All of that is what's got to happen if you multiply. A lot more to it than adding and subtracting was. So if I'm going to do that with the calculator, I'm just going to put in parentheses 3 plus 5i. Then open up another set of parentheses, and it was 6 minus 2i. Minus 2i. And it does all that stuff in the background so that you don't want, and I'm absolutely fine with you doing it with the calculator as far as the operations with the complex numbers. I'm not going to ask you to show me how you got there. The calculator is absolutely fine with me on doing that. Multiplying two complex numbers, you are absolutely welcome to do it with the calculator. If you want to do it by hand, that's fine too. But I'm not saying you have to at all. Let's do a division problem with these. Okay, division problem. Let's just take that same complex number, 3 plus 2i, 3 plus 5i divided by 6 minus 2i. If I were going to do this by hand, there's a lot more knowledge that has to happen here. You have to use what's called a conjugate, and the conjugate is 6 plus 2i, and then you got to multiply 6 plus 2i times the top and the bottom to get that to work. That's a whole lot of multiplying. That's not only do you have to know that it's conjugate, so that's two things you have to know, and then you got to multiply. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 multiplication problems that you got to do, plus the addition subtraction that you got to do. So there's about 20 operations in doing that one division problem if you do it by hand. You can do that, and it works. Or you can go to your calculator and you can type in parentheses 3 plus 5i, close parentheses, divided by parentheses 6 minus 2i, and hit enter. And it gives me the decimal there. I want to change that to a fraction, so I'm going to hit math, enter, enter, and get 1/5 plus 9/10 I. 1/5 plus 9/10 I. If I did this by hand, I'd get 18 plus 6i plus 30i plus 10i squared on the top, 10i squared, not x. On the bottom, I'd get 36 plus 12i minus 12i minus 4i squared on the bottom. And then you do all this simplifying there on the top. Get 36i on the top. Hold on, let me grab this answer and move it down so I can show you that step. That'd be 18 minus 10 is 8 plus 36i. On the bottom, you got 36 plus 4 is 40. And then these cancel each other out, so that's over 40. And then you split that apart into 8 over 40 plus 36 over 40 I. And that's what it simplifies to be. 8 over 40 reduces to 1/5. 9 over 10 is 36 over 40. It's the same thing. Lot more work involved in doing that, and that's why one of the reasons I say, hey, you got that graphing calculator, you paid $100 for it, use the thing. It does some neat things for you, especially with the complex, because honestly, there's not a whole lot that we do besides just outright doing operations with these. There's not a you need to know how to do this for something later. not in Math 100 and 110. Now, if you guys were going to be math majors and you were going to go on and take some higher level maths, hey, that's a different story. We'd be doing different things, and we probably wouldn't be starting with Math 100 and 110. So be mindful that your calculator does some neat things for you that are helpful out of that. So for these sections, page 145, 1 through 37, page 29, 45 through 85, page 38, 1 through 45, and then 51 through 69, and then page 103, 17 through 79. Odds on all those. Those would be some practice problems from your textbook out of that. As usual, I'll send you a link to the videos for today's lessons and just reiterate which labs and quizzes that you should be doing out of that. Make sure that you're getting all your labs and quizzes submitted for everything we've done up through today by next Tuesday. That's when their due dates are. Okay. And then the next half will be due the day before the final. Okay. So make sure you're getting those done. A lot of you have done some quizzes, haven't gotten a whole lot of labs, but I figure that changes as we go through this week, and especially having Thursday to get all that stuff done. Whether you use the scanner in the room or on at your campus, or just take a picture of it with your phone and upload that picture on Canvas. Whichever way you do that is fine with me as far as the labs go. And if you have trouble with it uploading, shoot me an email and I'll try to troubleshoot from home. And if we can't get it troubleshooted, we'll have that documented that, hey, you tried to submit it and it didn't work, and then we'll figure it out on Tuesday of next week. Again, email me if you got questions. Let me know what you need, and make sure that you include a picture of what you're working on in your email so that I can try to help you as best I can. No class this Thursday. We'll pick back up next Tuesday morning, 9 o'clock, and go from there. I hope you guys have a great week and a good weekend, and I'll see you next Tuesday.